Good morning. Welcome to Cisco Live. Welcome to Berlin. My name is Raghu Nambiar. I lead the emerging technology solutions within Cisco's data center business group that includes big data, analytics, and Internet of Things. Today's primary focus is going to be on big data. I assume that big data is a topic of interest for you. Some also associate with some of the industry standard consortia. Recently chaired the TPC's benchmark standards committee for big data that produced a benchmark called TPC XHS, which is industry's first standard for benchmarking big data systems. So if that is a topic of interest, I would like to have an offline discussion with you. As you know, big data is one of the most talked about topics in the industry and research. Few years ago, it was a Web 2.0 company, centric, challenge. But now it has become integral part of enterprise IT ecosystem across major verticals. We started this program within Cisco's data center business group about 3-4 years ago. So we are seeing a tremendous traction for our solution in the enterprises. If you look at some of the analyst reports, according to which 2016 is expected to be a year when big data is going to go mainstream. Significant opportunity for vendors, practitioners, and of course end users. Now let's have a quick look at some of the major drivers for big data. I'm pretty sure you are familiar with this. Three major drivers. One is people, the number of people connected to the internet. Second one is the Internet of Things, devices connected to internet. People generate data, social media data, devices generate data, IoT data. Then of course the most important is the new emerging applications like recommendation engines, personalized services, anomaly detection. Okay, I want to give you a simple example. If you look at Amazon, the world's largest online retailer, okay, significant part of the revenue is coming from recommendation engines. Okay, so when you buy a book or like buy a electronic item, when you check out, it is going to give recommendations that, okay, by the way, people who bought this also bought these other things. Okay, that's generating, I believe, $15 to $20 billion for them. Okay, it's a pretty significant, business opportunity. The rest of the IT industry is growing at about 4.5% year to year. Okay, but the big data is growing 7 times or 27% year to year. Okay, it is expected to be a $34 billion business by 2017. Okay, and most importantly, it is going to drive about $240 billion of IT spending. Okay, so for example, your Oracle or Microsoft and SAP private cloud strategies are expected to be significantly influenced by your big data strategy. So if you look at the big data IT spending, it is expected to be like 50% on infrastructure, 24% on software, and 26% on services. Okay, if you look at the traditional enterprise applications, the IT spending is around 70 to 80% on software and 20% on infrastructure. Here, the equation is slightly different, primarily because a lot of the software powering a big data is generated, developed in the open source community, like Hadoop and NoSQL distributions. And it's a worldwide opportunity, pretty much in line with other enterprise applications. So now I want to, as I said, we have been working with on this program for 3 to 4 years. Let me share some of the top observations based on working with our customers and partners. Number one is, generally the value proposition of big data is known today. okay, compared to a few years ago. Do you agree or disagree?
Yes.
Okay. Second is there are common deployment scenarios and use cases that at least our customers are starting as a first set of use applications. A few years ago, it was pretty difficult, very hard to find Hadoop expertise. Now, there are Hadoop expertise available internally, and there are a lot of consultants, who is trained on Hadoop and NoSQL and other emerging technologies. So another observation is that shortage of data scientists who can translate, the data collected into action. Okay, there is still a shortage that is impacting overall adoption of big data. Next is when you are using your big data for mission critical or SLA driven applications, okay, the dependable and high performance infrastructure is extremely critical. Then, of course, when your application mature in your in your environment, you will have to deal with the security, compliance, and data lifecycle management. Next one is big data in a typical enterprise. It takes 2 to 3 years to mature. Starting with 1 or 2 use cases, POC, going production, identification of new applications, integrating these new generation applications with existing ERP and EW system. Okay, overall it takes 2 to 3 years to mature in the enterprise. So now let me spend maybe a couple of minutes on common deployment scenarios. So the first one is using Hadoop as a data lake or data hub. Okay, a data lake where you store or dump all your data, and different applications building pipes to extract the data and process the data. Next one is like new generation applications. I touched upon this one before, like recommendation engines, personalized services, process optimization, anomaly detection, predictive analytics. These are some of the top use cases that we see. So another use case is augmenting traditional EW enterprise data warehouse applications with the big data, like offloading ETL processing, for example. So other one is enhancing traditional applications with the big data. One example I want to highlight here is SAP Vora. Vora, V-O-R-A. So this is a product SAP announced last year. Cisco is one of the first vendors to develop solutions with the SAP Vora. The way you want to look at is SAP HANA for traditional analytics, a column store, relational database management system. Vora is a Hadoop tier, okay, and they run Spark framework on top of that. So you have a traditional analytics and emerging big data analytics, and bringing together. That's what the Vora platform does for you. And another common use case is replacing traditional applications running on mainframe and other platforms with Hadoop and NoSQL. So significantly lowering the cost of ownership. So these are some of the industry vertical use cases that we have seen. I'm not going to spend a lot of time on this one. The slide will be available for you. I mean, there are several verticals listed here, and top use cases. Any questions so far? Okay. So now maybe I spend let me spend a couple of minutes on Cisco solution. Cisco solution is powered by Cisco UCS, Unified Computing System, or Data Center Compute Platform. How many of you are familiar with UCS? Okay, pretty much all of you. Okay. So I'm not going to. I mean, as you see here, broad portfolio of switches and servers, and under servers and blade servers as well as rack mount servers. For the big data and analytics, primary focus is going to be the rack mount servers with the internal storage and clustered together. So recently we took the whole big data program under the integrated infrastructure initiative, and integrated infrastructure is an industry standard term that is tracked by IDC and Gartner and others. And as you know, we are already a big player in the space with the FluxPod, vBlock, and other solutions. So our integrated infrastructure for big data, now we are at the third generation of our platform, widely deployed across major industry verticals. So our area of focus are three: Hadoop, NoSQL, and analytics. And we have a broad ecosystem partners in the space. I'm going to talk about that in 1 second. And some of the major Hadoop distributions are in our global price list. So you can buy the hardware and software from Cisco and get support from Cisco. And we also developed a software called UCS Director Express for big data. It's a one-touch deployment tool for Hadoop distributions. Okay, with this software, you will be, the software will discover the topology, network topology. Okay, create service profiles based on our best practice guidelines. Blast the service profile and make the service ready for servers ready for application. Then install the operating system, install Hadoop distribution of choice, and apply all the known tunables for the system side as well as on the software side. It's all like basically like with the software, you're getting a appliance-like experience, like single click with a few inputs. You will have the cluster ready, whether it is very small cluster, typically 8 nodes, or 800 nodes. And the solutions are available as a Cisco validated design. And do you know what is Cisco validated design is? CVD.
Yes.
Okay, CVD is basically an end-to-end deployment guide. We have that for all the major software distributions. So the architecture is very simple. I'm sure most of you have have been running UCS B series blades. Okay, with the fabric interconnect is like a Nexus switch with the UCS manager software embedded. Okay, and bunch of rack mount servers for compute and storage. So there are 4 popular building blocks. This is based on the performance and capacity demands. The first one is C240. It's a 2 CPU server with an option of 12 large form factor disk drives if your application demands a lot of capacity, or 24 small form factor disk drives if the application is demanding a lot of IO bandwidth. The last one is the new platform that we have purpose built for big data and analytics applications called C3000. Okay, it's a 4RU box with 60 disk drives, large form factor, with an option of 1 compute blade or 2 compute blades. 1 compute blade for capacity sensitive applications, and a 2 compute blade for where you can get a good balance of compute and IO bandwidth and storage capacity. These solutions are available as a single SKU bundle. Okay, and typically our customers use these configurations as it is, or use a template to build larger configurations. These 5 single SKU bundles are based on the performance and the capacity requirements for various applications. I want to highlight maybe a couple of them. These 2 are most popular in the Hadoop space. Okay, the first one is a 16 server configuration with the C240 with the small form factor disk drives. Second one is C240 with the large form factor disk drives. Here it is performance. Here it is capacity. So I'm going to skip this slide. Okay, want to spend maybe 30 seconds on our broad partner ecosystem. As I said before, we are focusing on Hadoop, and as you see, we are partnering with the major players here: Cloudera, Mappa, Hortonworks, IBM, and Pivotal. And other area is massively parallel processing. You see like a Pivotal and Actian in that space. And in NoSQL, there are a bunch of partners. And Splunk is one of our top partners here. How many of you are using a Splunk? Oh, okay, great. And on the data integration space, Cisco has two solutions: data virtualization. There are a few sessions on data virtualization here if you're interested. Other is data preparation, a new solution that we announced last year. And on the analytics, you see like traditional vendors and some of the emerging vendors. And as I mentioned before, the solutions are available through our Cisco validated design. So basically an end-to-end deployment guide, which guarantees out-of-box performance. So that's all I have for today. Now let's have a few questions.
Yeah. For me, yeah, from a, let's say, network perspective or from a server perspective, yeah, I see big data as an additional application that runs on the infrastructure. What do you see is a unique or special, let's say, challenge when it comes to big data? Do we need more I/O in the storage or more data at the networking side? What are special for big data?
Okay, I mean that's a very good question. So typically, when you talk about big data, there are two challenges. Okay, one is storage capacity, right? And the second is I/O bandwidth when you process the data. And in most cases, if you look at Hadoop, it is sequential read. So I/O bandwidth is the critical. And on the networking side, when you have a large number of systems clustered together, there'll be like a lot of data going back and between the systems, right? So typically, our recommendation is 10 gig and dual 10 gig for high availability.
And for me, I'm in the picture. Let's build a cloud and make it multi-purpose, yeah, for every application we ever have. Would you suggest for big data, you need a special, let's say, rack or special hardware to dedicate this only for big data applications?
Typically what we see in big data is you have to store large amounts of data, and applications are very I/O intensive. So that means you don't have much resources available for other applications. So in most cases, what we see is dedicated clusters for your big data.
Okay.
And in certain cases, we see Hadoop as a service in for a couple of reasons. One is you want to run two Hadoop distributions, right? A group A within your organization likes Hadoop distribution A, and group B in our organization likes Hadoop distribution B. So you want to have two Hadoop distributions on the same infrastructure. In that case, you have to virtualize and provision for a group A and a group B. Second is if you want to use the same platform for test and development and production at the same scale. Okay, in that case, you might want to virtualize and create a virtual cluster for test and development and another virtual cluster for production on the same infrastructure. But in most cases, it is bare metal dedicated clusters, being deployed. That's what we see.
Okay.
So I was basically having the same kind of question, but you replied to that. It is better probably to do bare metal deployments than virtualization, right? Because we had a case with MAPR application where they wanted to do that for some reason on the virtualized platform. But my experience has been that what they've been requesting is to get the entire compute and storage resources from each of the nodes. So.
Yeah, actually, as I said, in most cases, what we see is a dedicated bare metal cluster for Hadoop-like applications. Because I mean, these applications, especially like SLA-driven applications, can really use the compute power and I/O bandwidth and the network connectivity.
Do you have any time shifting of the processing for these big data? Do you expect them to run 24/7, or is there are people using it in a way where they'll push off the workload and the processing to off-peak hours?
Yeah, I mean, if you're looking at the new generation of applications like recommendation engine, like personalized services, like anomaly detection, it's pretty much 24/7. But if you're looking at augmenting traditional applications with Hadoop, for example, you have a EDW application on traditional systems, and you want to use Hadoop for ETL, then maybe like the ETL processing is done in a in a window. It may not be 24/7. Yeah.